right, find the absolute maximum, absolute minimum of the values of the function. Now, is this a closed interval?
Yeah.
Yes, it is. It is a closed interval. Okay, it looks like it's going to be closed because I have endpoints that are also included, right? But for it to be a closed interval, what else has to happen, especially for this piecewise?
Continuous.
Has to be continuous. So for it to be continuous, I have to check what it's going to equal to in the middle. Mm-hmm. So it's 2 that both values have to be the same, right? Okay, so it's going to be at 2. So I'm checking these ones right here. So plug in 2, I get 2, 4, 3, right? And right here, it's going to be 2, that's 4, minus 10 is negative 6, plus 9 is positive 3. Okay, so it is continuous over this interval, right? Good. Yeah. All right. Find the absolute maximum and minimum. So I have to go through and find a derivative for each one. Okay, so now let's start with the top. So you know what? Having red is not working out for me here. There we go. All right, so it's going to be, the first one is going to be just 2, right? Mm-hmm. Now, that would be my f prime basically, right? So can I set this one equal 0? No. No. Do you know why it's not? What type of line is this? It's linear, isn't it? It's just straight. It's not going to have any curves, so there is not going to be a min or max because it's not curvy. Just a straight line. All right, now let's go ahead and check the bottom one. So if we're checking the bottom one, that's going to give me 2x minus 5, and if I set that one equal to 0, it's going to be 5 over 2 is equal to x. Now, serious. Is that in my interval?
No.
It is 2.5, right? Mm-hmm. So it is in my interval. So this is 2.5. So it is 2.5. So that means it's going to be a min or a max or something. So I get critical values there. So now I have to start checking endpoints, right? Start checking endpoints. I checked the 2, right? I checked the 2 and I got 3 on both of them. So let's go ahead and check the 3. So if I do the 3, I'm going to change up colors because I can. That's why. All right, so check my 3. So 3 squared minus, so 9 minus 15 is negative 6 plus 9, 3?
3, yeah.
3 again? Oh, okay. So let's see. So this one is at 3. When x, that's f of x is, it's not f of x. It's f of 3, right? Okay, f of 3. Yeah, f of 3 is 3, right? Okay. And we said f of 2 is also 3, right? So that's going to be like some weird parabola thing, right? Okay, so now let's do 2.5. Or 5 halves. I like 5 halves better because 5 halves is so much easier to put in there. So that's going to be, so 5 halves, that's going to be 25 fourths minus 25 over 2. Okay, so 25 over 4 minus 25 over 2. And that's going to be plus over 4. That's going to be times 9 is 36 over 4. Yes? Friday, you're giving me that face again.
Where did you get that from?
Where did I get that from? What's 36 divided by 4? Say 9.
9.
And why did I not just write 9? I gotta have common denominators anyway, right?
Yeah.
Yeah, it's gonna make life a little bit easier. All right, so and I left this as fractions because it's gonna be even easier. So this is gonna be basically 50 over 4, right? They're all going to have common denominators. Yes? Okay, so yeah, all common denominators are 4 now. So 25 minus 50 is going to give me a negative 25. Negative 25, positive 36 is going to be 11 over 4. Which comes out to be 2.75. I think so.
Where did you get the middle?
Where did I get what?
25.
25 over this one?
Yeah, no, 25 over 2.
This one? Okay, so now, what's my x value?
Yeah.
2.5 or 5 halves. Okay, what is 5 halves times 5? There's my 25 over 2. And to make it the common denominator, it became 50 over 4. Okay. All right, so 2.75. All right, and okay, since I don't have any critical values in the interval of this, what else do I still have to check? Zero. Got to check 0, right? We haven't checked 0. Because like I said, we have to check all the endpoints. Okay, so it's also going to be f of 0 is -1. So now, given that much information, what do we know? Minimum is what? So this is minimum. And maximum is going to be, it's going to be 3. So if you notice, don't I have like 2 3s? Yeah, so I have a max here when it was there, and I also have a max here. So the maxes are going to be the same. So I write them both because they're both the same. All right, we ready? Move on. Let's clear this one up. Okay. Rain gutter is to be constructed using a piece of aluminum 12-inch wide. After marking a length of 4 inches from each edge, the piece of aluminum. Where am I at? Piece of aluminum is bent at an angle theta. So we have it here. So bent at an angle of theta, and the area of a cross section opening expressed in the function. So here's your function, and your interval is going to be between 0 and pi over 2. Now, why is it going to be between 0 and pi over 2? What degree is pi over 2? 90 degrees, right? So if I take this beyond 90 degrees, it would look like this, wouldn't it? It'd be folding in, wouldn't it? Yeah, it'd be folding in. I don't want to do that. So I don't want that. I want it to actually, 90 degrees would be the most I can go with that one. That's why that interval is there. So you have a formula. Say yes.
Yes.
Good. We have a formula. So that means that we could go and just do it. So I'm trying to maximize an area, right? So yeah.
Yes.
Okay, if I'm maximizing the area, I take the of the, yeah. I only have one thing, don't I? Don't I only have one value right here? It's not going to be like the problems that we did before in 4.1. I only have one variable. I'm not going to have anything odd. So, what type of rule is this? Inside, outside?
Well, yeah.
Yes.
And.
Chain rule, right? So, it's going to be a chain rule. So, the derivative of the inside is going to be negative sine. So, negative sine theta, right? Negative sine theta times. Okay, so now let's go outside. What's the derivative of sine? cosine, and there's a 16 in front of it, so it's going to be 16 cosine of theta. No, this one's product. Why didn't you guys tell me that?
You said change.
You said.
I know I did, and I also told you I only got 4 hours sleep. So, okay, so why aren't you checking me on this? So it's product. Okay, so F and G. Friday, why'd you speak up? You, come on, you could have said it. You know what? Now you made me look bad there, Friday. Okay, so F prime. So that's going to be 16 cosine of theta times cosine of theta plus 1, and then product, so it's plus, and so derivative of this is going to be negative sine of theta, yes, times F, which is 16 sine of theta. Okay, so now let's go ahead and put stuff together. So as I do my distribution, I'm going to distribute it together and see what I get. So let me see. Yeah. All right, so it's going to be 16 cosine squared theta plus 16. That's going to be cosine theta, right? And that's going to be a minus 16 sine squared theta. Jess, and I really wish that would have been a plus 16 sine theta. Oh, that sine squared, that would have been so much easier.
Right.
Yes, because sine squared plus cosine squared gives me 1. Okay, so, but instead, it gives me something to work with. So, I only like having one variable or one term. So, my term here is I want to use as cosine. So, can I replace sine in terms of cosine, especially sine squared in terms of cosine? Say yes.
Yeah.
Okay, so Pythagorean identity says that. No, don't. No. This was not a computer problem. It's a projector problem. But I'm getting a new projector. They said it's here. Like some teachers actually already got them.
Yeah, environmental science teacher.
Yeah.
Oh yeah.
Kind of good. Yeah, thanks.
Okay, so hopefully it still works. Okay, so there you go. Okay, so we're saying that sine squared plus cosine squared is equal to 1. So I want to get rid of my sine, so I would do what using this identity?
Let's subtract cosine from both sides.
Excellent. So it's going to be sine squared is the same as saying 1 minus cosine of squared, right? You notice I don't put my thetas or anything in there because it's just an identity. It's whatever my theta would be. They always got to be the same. So it's going to be, change this out to a negative 16 parentheses and 1 minus cosine squared theta. Yes? Yeah. Okay. I'm going to need some more whiteboard for this, so someone help me copy this down. Insert page blank after current. Okay, so I have 16 cosine squared theta.
Plus 16 cosine theta minus 16 times 1 minus cosine squared theta.
There we go. Okay, so bringing down to my distribution, 16 cosine squared theta plus 16 cosine theta minus 16 and plus 16 cosine squared theta. Yes, right?
Yes.
Okay. Okay, so do the math. Combine like terms, so it's going to give me 32, right? Say yes.
Yeah.
Okay, so I have 32 cosine squared theta, right? Minus 16 cosine theta minus 16.
Plus 16 cosine?
Yeah.
Plus, you're right. Thank you. All right. Do they have a common factor? My common factor is what? 16. Let's take that out. Okay, so it's going to be 16 quantity 2 cosine squared theta plus cosine theta minus 1.
Oh, wait, isn't it the, minus cosine theta? Oh, no. I forgot about it.
Okay, no worries. And since I'm going to have something like this nasty thing, right? So all this is my dA d theta, right? Yes? Okay, so now all this comes out to be my dA d theta. So now if I want a min or max, what do I do? Equals 0. Thank you. Plug it in later on, but set it equal to 0. So let's go ahead. So if I'm setting it equal to 0, that's going to cancel out. So it's 0 because it's going to be 0 divided by 16. So that goes away. And so it's going to be 2 cosine squared theta plus cosine theta minus 1. Okay, so now let's treat this like a trinomial. Let's just say cosine is supposed to be x. So if you just treat it like that, it makes it a little bit easier to imagine doing this. So if I just say cosine is like saying x, so this would be x squared plus x minus 1, right? So think of it like that. It works out a little bit better. So 2 times negative 1 is, so equals negative 2. That's my AC. And then blah, blah, equals positive 1. Okay, so products. Okay, product that gives me negative 2 but adds together to be positive 1. Negative 2, positive 1? Positive 2, because this one right here is positive, right? So it's a positive 2 and a negative 1. So positive 2 and a negative 1. So let's go ahead. So it's going to be a 2 cosine squared theta and plus 2 cosine theta minus cosine theta minus 1, right? All this is going to be equal to 0. Factor by grouping. So I'm going to take out a 2 cosine of theta, and after I take that out, that's going to be a cosine theta. If I take out everything, it's going to be plus 1. Okay, I'm going to take out a negative 1, and it's going to be a cosine of theta and plus 1. So the common factor, so it's going to be 0 equals cosine theta plus 1 and 2 cosine theta minus 1.
How fun.
Okay, so set each one equal to 0. So if I set this first one equal to 0, that's going to be cosine theta equals negative 1, right? Yes? Okay, so cosine theta equals negative 1. What's theta going to be for my cosine to be negative 1? Yeah, cosine's the x value. It's no longer over up here. At pi, very good, at pi.
Yes.
So this one's going to be pi. There we go. That one's going to be pi. Now let's look at the next one over here. So this is going to be cosine theta equals positive 1/2. Unit circle, where's cosine theta equal positive 1/2?
Is it
Pi halves. Oh.
No. pi over 3. Very good. Now, yes, it's pi over 3. So theta is going to be pi over 3. Okay, theta is going to be pi over 3, and theta is going to be pi. Let's go back to my problem. What's my interval? 0 to pi halves, right? So 0 to pi halves. So is pi in this interval? No. Okay, so if my angle was pi, that wouldn't work out, would it? That would mean that it would go all the way over, wouldn't it? Yeah, so that's not going to work out. Anyway, all right, so the other one's going to be pi over 3. So find the angle that maximizes the area. So we don't actually have to find out anything else. We got that. It's going to be pi over 3. Now, endpoints. If theta was 0, would that have any area? It wouldn't have area because it would be a flat surface, right? Okay, and what about if I go straight up?
It's gonna be 90.
That's 90 degrees, right? That's pi over 2. I'm checking the endpoints also. So I'm going to do this one right here. So let's see what happens there. So at pi over 2, okay, what is sine at pi over 2? It's 1, right? Sine at pi over 2 is 1. Okay, sine at pi over 2 is 1. Cosine is 0. Okay, so this is 0 plus 1 is 1 times sine, which is 1, right? Okay, times 16.
16.
So at pi over 2, area, right? So this A of pi over 2 is 16. Now, it just got to be more than 16, doesn't it? So if it's more than 16, that works out. So it's going to be, what do we say, pi over 3?
Yep.
So pi over 3. So doing pi over 3. So cosine at pi over 3 is going to be 1/2 plus 1, that's 3/2. Okay, so sine at pi over 3 is rad 3 over 2. Rad 3 over 2 times 16. All right. I'm going to tell you it is going to work out.
12 by 3.
So this is going to be 8 times 3 is 24 over 2, 12 right 3. Yes. Yeah, 12 right 3. So what is 12 right 3? Just got to be more than 16, doesn't it?
More than 2.
Roughly 20.7.
A little under than 2.
20 point what?
7, 8,
3 decimals. 7, 8 what?
5.
So 7, 8, 5. There we go. So the maximum area is pi over 3. Theta is pi over 3. Oh, there's that one problem. You know what? Gives us something to do on Tuesday. Actually, no. Don't do this one. Don't do this one. I totally remember this one now. I remember this one. This one's a hot mess. This one's a hot mess.
What, the junk?
Yeah.
We're trying to analyze a cough.
Wind pattern. This is wind pattern contracts.
I remember last year trying to do this problem. It was a mess. Okay, don't forget, like, share, and subscribe.